Thank you, everyone. So my name's Tim. That's me. I chose that particular picture. It's nearly 6 years old today because it was taken at DjangoCon US 2019. I was a very young developer there, and DjangoCon US was kind of a real catalyst in terms of my interest and understanding in Django. And it gave me the confidence that it was something I could contribute towards, and it was a community I could be a part of. So it's quite special to be back at DjangoCon US speaking this time. So I'd like to start by saying thank you to the organisers for giving me this opportunity, and just for organising what's been a fantastic conference so far. So I'm a developer. I work for a company called Juno. We're a freelance management platform. So if you are a freelancer or if you hire freelancers, please do check us out. And I've been working there for a while, and I sort of got the reputation as the performance guy. And as a result of that, over the past year, past 9 months especially, I've been given lots of performance work. And over that time, my ideas about kind of what is performance work has shifted quite a lot, I feel, which is the kind of inspiration for this talk. So it won't be comprehensive. I think it'd be pretty difficult to do a performance talk that's comprehensive anyway in 45 minutes. It's more I guess, personal journey revelation, but I hope it'll be useful for you. So performance. If you have been to a talk on performance before or read an article or anything like that, the first thing you will see is profile first. And there'll probably be a quote from Donald Knuth, hope I'm pronouncing that correctly, about premature optimization being the root of all evil. Arguably a misquote taken in isolation like that. And just so we're all on the same page, by profiling, I'm talking about measuring things. There's lots of things you can measure. I'm going to focus mainly on kind of time spent in this talk. But we're told to profile first, and I think we can all agree that's good advice. I mean, for one thing, it's just good common sense, right? There's no point spending hours and hours squeezing every last drop of performance out of something if, in fact, the code it took you 30 seconds to write is already fast enough, or maybe kind of really fast for your use case. But supposing you do realize that it's not fast enough, well, you need to know what to optimize. You need to know what are the slow bits. What are the bottlenecks? And sure, you might have some intuition about that, but our intuition is often wrong. And so profiling is just sensible to make sure you're not wasting time optimizing the wrong bits. Also, you want to know if you've made progress, right? If you're doing lots of work trying to make something faster, it's nice to have a before and an after so that you can tell if you've done a good job or not. So yeah, profile first is good advice. But there's a but, and it's quite a big but, and that's that good advice is only really useful if you follow it. I'm perhaps a bit like Alice in Wonderland, who very seldom follows it. I don't know about you. I think if I look back at lots of the work I've done, profile first has turned into profile hardly ever. Or maybe profile as a last resort when all the other things I've already tried don't work. Even in performance work, I like to think, oh yeah, I can look at that code and I can spot the n+1 issue here. I can notice there's an index missing there. And for those reasons, you tend not to profile. I suspect I'm not alone in this. I think profiling probably fits into that category of things that everybody talks about, but far fewer people are actually doing. And of that subset, probably a lot of those aren't doing it right. I went online. There are a few companies that kind of do surveys on how developers use APM tools. And one kind of common thread that came up in kind of lots of the things that I was reading was that we tend to use them reactively. So this survey said that the primary driver for adopting APM is to fix problems. And another survey said organizations are still more likely to be reactive rather than systematic. And, in some sense, this might be reasonable. But I think we can do better for a few reasons. For one thing, it's not the best look to have your performance issues being raised by your users. Ideally, you want to address things before they become an issue, rather than scrambling to fix them after it's a real problem. You want to optimize things for lots of reasons. It might not just be kind of user experience. It might be things like how much resources you're using or environmental reasons. And that reactive style of profiling isn't going to cut the mustard there. Likewise, SEO. So one of the big reasons I did lots of optimization work is our page load times were affecting our SEO results. And without kind of some systematic profiling, that thing's never going to be flagged. So there's some good reasons why kind of we can do better than reactive profiling. But there's a more important reason, and I think it's that the alternative is just so much better, which is what I'm about to talk about. So I don't know if you've ever tracked something like a bad habit. Things like screen time and social media usage are common ones. For me, I drink a lot of tea, and I spend a lot of money on tea, and if I'm honest, cakes and pastries too. And I knew this to be the case, and I had a vague sense of, I was spending this much money on it. But this, by the way, over there is the coffee shop where you'll find me virtually every morning, programming away. I thought I had a good idea of how much I was spending. But a couple of years back, for a month, I recorded all of my coffee shop expenditure. And the results were horrifying. My experience when I started profiling in a more systematic way on the site that I'm working on were very similar. I was just completely shocked at what I thought I knew being completely wrong. So bear in mind, this is a company I've been working for about 5 years. I thought I had a pretty good idea of where our slow pages were, what our issues were, and there were just so many things I had no idea about. So what is proactive profiling? Proactive profiling, by the way, is just a term I've come up with. It's nothing official. I'm just using it for the purpose of this talk. Profiling to understand rather than to fix. It needs to be broad. So rather than just diving deep into the particular view or the particular endpoint that's not performing well, you're taking a broad look at some very basic statistics. So you get an idea of the distribution of what's fast and what isn't. And then you combine that with the drill downs. So once you know which bits are slow, then you know which bits to focus on. Ideally, this should be on production data, because it's not just about what are the slow views, it's about what are people using, right? If you're trying to improve your environmental footprint, there's no point identifying all the resource-intensive endpoints if, in fact, nobody's using them. Local profiling is still useful, and I'll talk a little bit more about this later. So there's lots of third-party services that you can use to do this. Sentry, New Relic, Datadog. I was going to kind of compare them, but kind of looking into them a bit, I found they all offered mainly the same features. And I think what's more important is having fluency in whichever APM tools you're using rather than the particular tool. I'm also aware some of these tools are quite expensive and not all companies can afford them. So some alternatives are to use open source libraries or just roll your own to gather in the low fidelity stats. It's easy to write some middleware that captures how long each request is taking. And then maybe combining that with something like Django Debug Toolbar, which you can use on production, for your admin users. And that way you can get the broad spectrum as well as the drill downs on production. The third-party services offer a lot of convenience, but there are ways around it. And finally, profiling regularly. So I don't know how regularly is regular, but I suddenly found doing this repeatedly gave me more benefit as time went on. So what does it actually look like? Well, it's very simple. What I tend to do is I tend to find what are the 10 slowest pages on my site by average. If I were to do that right now, I could tell you straight away 6 of them will be from the Django admin page. And I can also tell you straight away that there won't be very many hits on those pages, and they're only accessed by devs anyway. So then I would exclude all my admin pages from my results, and then I would look at the top 10 again. And then maybe I look into them, and I notice lots of them are list views, and I see, oh, actually all of these views have a thing in common, and that's they're all spending lots of time populating drop-down filters, and they're all spending lots of time on the pagination component at the bottom, say. And so you begin to develop these kind of broad patterns about what areas of your code base are going to give you kind of the most bang for your buck. And depending upon what it is you're trying to do, you might want to look at different things. So one problem we had is that actually our site was pretty fine for most users, but we had a small proportion of users that were really heavy users and had lots of data. And actually, it was that our views weren't scaling properly. Looking at the P95, so that's the top 5% slowest pages, is actually a much more useful metric than the average for that, because it's identifying where do things not scale. Likewise, if you're wanting to profile to improve your environmental footprint, you're probably more interested in that total column. You're actually probably more interested in kind of not time at all, but some other metric. But it'd be the total amount that you're interested in. So it's nothing mind-blowing, but I have found it to be just a massive game changer in a way that I couldn't imagine. Not just in terms of performance work, but it's affected, I think, my whole programming. So I'll try and kind of convince you why I think everyone should be doing this. So for one thing, you notice the kind of broad trends, what I'm going to call performance topology. And it's not just kind of, oh, we're using paginators that are slow. It changes the way you view kind of performance. I was forced to stop thinking about views as fast and slow, and rather to think of them as, well, this one's quite fast, but it's volatile. Or this one is fast, but doesn't scale well. Or this one's actually just slow all the time. By spending sort of time just looking and exploring, just having a bit of a play with the data, you begin to develop a much more nuanced view of what's going on with your site. And because your focus is different, you notice different things. So I'll give you an example. Here's some profile from the site. I've changed the names of some of the code, but it's a screenshot taken from our APM tool. The way it works is time goes horizontally, and each bar is a layer of the stack. So those top 2 bars, the last bit of middleware, and then the view, and then the yellow and the purple, that's hitting the database. Now, if I was profiling this in a reactive way, I would straight away look at that massive query that's taking 5 seconds and say, right, we've got to sort that out. And then the next thing I would do is I would look at the following 5, 6, 7 seconds in the view. And I'd be like, well, what's going on there? What was going on there was massive overhead creating the query sets with all the prefetched data. But what I definitely wouldn't do is look at that final 1 second. And there's actually loads of really interesting things going on in that final 1 second that actually turned out to be really important for improving the overall performance of the site. They weren't bottlenecks for any given view, but because they were everywhere, they had a massive impact. And this is how profiling to understand, rather than like trying to hectically fix a problem, it allows you to notice different things. You gain more concrete insights. So lots of the advice you will see on performance is quite woolly. That's not a criticism of the advice. It has to be woolly because it's dependent on so many things, right? It's dependent on your infrastructure, the nature of your site, what you consider good performance. But when you spend time looking at data, it kind of puts flesh on the bones of that advice. And you can say, actually, no, I know exactly when I need to use only and defer, and it's for these particular models or in these particular cases for my situation. But you only really get that flesh by spending time seeing what is fast and what isn't. Increased confidence considering trade-offs. So programming is full of trade-offs. It's trade-offs everywhere. And in the past, when doing work, I would see a view and I'd think, okay, we're doing a couple of extra queries there. I could speed that up. But then I would make the changes and all of a sudden the code was less readable. And I was thinking, would I understand this if I came to it fresh or if I looked back at it in 6 months' time? And it felt like a choice I had to make between performance and readability, or whatever the trade-off is. But once you have a bit more concrete understanding of what things are, it makes those trade-offs easy. You can say, okay, yeah, that query that I'm saving, I know that's only going to be 1 or 2 milliseconds. And this view is going to be roughly 150 milliseconds. Actually, in this particular case, it's a really easy choice. Readability wins, not for the sake of 2 milliseconds. And so in day-to-day programming, it just makes all these little decisions so much easier, even when you're not doing performance work. As an aside, you gain some quite interesting insights about kind of how your users are using your site. If that was your primary aim, I wouldn't advise using APM tools. There are much better tools for doing that. But yeah, that's an aside. The next one I think will be important. And that's just, it's really, really effective. There were all kinds of improvements we made after we started profiling systematically that resulted in a really, really big change. So that statistic there, 395 milliseconds to 218 milliseconds, that's the average server response time of our template views. And it's actually filtered down to 200 responses, 200 status responses, because the other ones were a lot faster, and I felt were kind of made the statistic less honest. So that's about a doubling in the page load times. Really quite significant. Also, just spending time in whichever APM tools you use is a really useful skill to have. On the rare occasion that there is a genuine incident, being able to get to the root of the problem really quickly is just useful. Lots of the kind of platforms, you have this massive array of options, and they're difficult to get your kind of head around. So time spent in them is often not time wasted. So hopefully I've convinced you that you all need to be profiling on a wider range, but you do also need to zoom in and profile, kind of do the deep dives. And there are a few things I found that have been useful when doing this. One is visualizations are helpful. Obviously, we're all different, and we all kind of learn and see things in different ways, but some kind of visualization where you're able to kind of see where the bottlenecks are is useful. Don't just look at a single event, especially on production. You get a certain amount of noise. You do a deep dive into one particular request, and it looks like one thing's a bottleneck. You do it again, and it looks like a completely different thing is a bottleneck. And you need to do this several times to build up a picture of kind of the true nature of what's going on in a particular view. Likewise, don't just look at a single user or a single whatever the thing is that varies across your site, because sometimes a bottleneck might be restricted to certain profile types, say. Try and look at slow and fast examples. They each give you different insights. And kind of as you look at these different things, just for a given view, you build up a really nuanced picture of what's going on. I mentioned earlier local versus production. I do think it's important that you're able to profile in production, but local is really useful too. You get different issues on local and production. So you might look at something locally and spot an n+1 issue, and you think, okay, yeah, that's obviously the problem. But then when you look on production, because it's a scaling issue. Actually, there's a count somewhere that's taking a much larger time than the n+1 issue. As your data changes, so where the bottlenecks are will change. So try and profile on both. Production metrics are obviously a better reflection of real-world usage, but they tend to be more volatile. You get issues like the noisy neighbor problem. Depends what time of the day you're working at, how kind of much load your site is under. And for experimentation, actually, profiling locally I found to be a lot more helpful. I get much more consistent results. And you don't need to deploy too. One way around this is using the production shell for testing queries. And if you're on Django 5.2, a top tip is to write some profiling helpers and put them in the auto import to reduce that friction. Both give different insights. So you've done your profiling. Very likely, with a web app like Django, it's going to be something to do with the ORM that is going to be an issue. And I can think of no better place to start than the Django docs. This data access optimization page is a treasure trove of tips and techniques. If you haven't read it, read it. If you have read it, read it again. I think it's like your favorite book or your favorite movie, and every time you come back to see it, you notice something different. In fact, I was going to find a quote to include in my slides yesterday. I didn't in the end, but I read something and I was like, oh wow, I never realized that. And it's kind of changed my view on a couple of things. So I can't go through that, but I can talk through some kind of foundational principles that I think most of the things on that page flow from. One is, so for quick, simple database queries, a large proportion of that time is spent in the network layer. So just doing some manual testing, I found that for a query taking 1.5 milliseconds, about 65% of that time was not spent in the database, but was spent transferring back and forth. That number may vary depending upon your infrastructure, and other things, but it's a significant amount of time. One way to think about this is to imagine yourself, and the corollary of that is you don't want to make repeated calls, right? If you're wasting all this time in the network layer, one big call to the database is going to be more efficient than lots of little ones. And the way to think about this is to imagine yourself in a large warehouse. You're not going to, if you've got a list of 20 things to get, you're not going to walk to the back, get the first thing, walk back, then do it again, spend 5 minutes walking to the back of the warehouse, get your second item, go back to where you're from. That's just not what you would do. You would bring your list with you, you would go to the back, you would collect everything, and walk back again. That's, I think, the way to think about it. Query sets are lazy. So what that means is they're not going to fetch that data from the database until they need to. Normally that means when you evaluate them or you start iterating through them. If you do if query set, if you convert it to another type, like turning it into a list, these are the things that are going to cause the query set to actually hit the database. But before that, they won't. Query sets internally cache results once evaluated. So once you've got those results, it's not going to keep on doing that long database hit. And your related entities aren't fetched by default. These are the kind of important concepts to understand. So a common thing is an n+1 issue. So let's imagine you've got a problem with coffee shops, and so you create a Django app to help you with that, and you have a coffee shop model, and you want to iterate through your coffee shops. Well, what's going to happen? That first line, nothing is going to happen because query sets are lazy. The second line, when you start to iterate, we're going to get, can everybody read that, by the way? Do I need to zoom in? Can you give it a thumbs up? Is that good? Great. Yeah, it's going to say select these fields from the coffee shop, and we're going to get a table back like that. It's only using one database hit, everything's good. But let's suppose I want to support local business, and so I record which of these coffee shops are chains. I had a chain foreign key. And so now, instead of just looping through and printing off all the names, I'm going to loop through and I'm going to print off if there's a chain or not. This time, first part of that iteration, I'm going to do one hit to the database. I'm going to fetch all those things. Then once, actually the first iteration, it's not going to do another hit. Django will know there's no related chain entity, and it won't even try and fetch one. But then I get another query sent off to the database, and I get some data back. And I do a third query off to the database, and I get some data back. And you can imagine if I had 100 coffee shops, lots of with chains, there's going to be lots of hits back and forwards to the database. It's like being in that warehouse and getting items one by one. We don't want to do that. And so Django has this thing called select related. And instead of doing the repeated things, what select related does is when we iterate, we get a slightly different query. We get what's called a join. And Django joins the coffee shop table and the chain table. And we get one table that's returned. And so it's only one trip to fetch all of the data we need. That's great. But then let's imagine I start adding a review model. And my review model is to review different coffee shops. And notice multiple reviews can be read for a single coffee shop. And perhaps I want to list all the reviews. The same thing's going to happen as before. We fetch the coffee shop list, but then when we hit that line which says for review in coffeeshop.reviews.all, Django doesn't fetch related entities up front. We're going to have to hit the database again. We're going to say select this review where the review.coffeeshop ID equals 1. And then for the next one, and then for the next one. And we've got another one of these n+1 queries. So why not use select related again? That seemed to work last time. Well, imagine if you did. Think about what that joined table would look like. It might look something like this. So I've joined the coffee shop table and the review table. So the first kind of 5 columns are my coffee shops, and then I've got the review. But if we look at lines sort of 2, 3, 4, we can see we've got lots of repeated data there. We're fetching the data on the coffee shop multiple times. And if I had a coffee shop with hundreds of reviews, I'd be transferring all of this data about one coffee shop hundreds of times. It's not very efficient. And so instead we have this thing called prefetch related. And what prefetch related does is it does 2 queries. It does one query just to fetch the relevant coffee shops. Once it's got that, it knows exactly what reviews you need, and it then does a second query to fetch the reviews. And that way we're only passing back the data for each coffee shop once, rather than hundreds of times. So we've got prefetch related and select related. And maybe you've come across something like this. So we use select related for one-to-one and foreign keys, and we use prefetch related for the reverse direction of that foreign key, or the many-to-manys. And that's a useful rule of thumb, but I try to stop thinking in those terms these days, and prefer to think about what is the join? What's the joined table going to look like? So let's imagine I want to print off all of my reviews. Well, each review is going to give rise to one coffee shop. So select related, it's the forward direction of the foreign key, right? So select related seems like the sensible option. But maybe I've only got 5, 10 coffee shops and I've got thousands of reviews. What's the joined table going to look like? Well, I'm going to have all of this repeated data for my coffee shops. There's only 5 coffee shops, but for each one, I'm requesting it 200 times. That's not efficient. Actually, prefetch related would be the better one to opt for in that particular case. Or maybe you've got a more equal ratio of coffee shop to reviews, but maybe your coffee shop table is really, really wide, and you've got lots and lots of columns. It's going to be lots of data, and all you really need is the the name of the coffee shop. If you do select related, you're going to pull in all of that unnecessary data. And actually, you can use the prefetch object to say, actually, I only want the coffee shop name. That's going to be a much more efficient way of doing that particular query. So rather than thinking select related is for these things, it's better to think, well, what's the join going to look like? And actually, once you start profiling, this is another one of these things I've just noticed you get a better instinct for. So ORM optimization. It can be difficult. I'm going to quickly go through the next few bits. There are a few useful tools that are useful for debugging. One is to log your queries. You can do that via settings. You have this connection object, which you can use to get your queries. And you can use that to write things like middleware. This is the thing I load into my shell automatically, and it tells me how many queries are on a particular thing. A few other useful tools. Every query set has a query object, and the string form of that gives you the SQL. And it has an explain object, which tells you how the database is going to deal with that particular query. These are useful things. As well as that, when you're getting started, it's sometimes difficult to know, has this query set been evaluated? One thing I always used to get confused about was, if I call .values, is there a cached result of everything? And so this result cache, which is, I guess, technically a private method, can be really useful for just debugging things. Maybe you think the thing should be select related, but it's not. Likewise, for an individual model instance, you can look at the underscore state fields cache attribute, and you can see what has been prefetched or selected related. Those tools are also really, really useful if you want to write your own kind of auto-optimization features, things that automatically do the prefetching and selecting for you. The other things I find those really useful for is writing regression tests. So if you've got a function, and it's really important that function returns something that's lazy, these things can be really useful for writing tests to make sure that stays that way. Low-code solutions. Maybe you've done some ORM optimization, and as developers, especially developers who are interested in performance, we have all these tools at our disposal. We've got kind of caching and in-depth knowledge about indexing, and we see a performance issue, and we get out the performance hammer, and we start hitting it. But actually, sometimes taking a step back can be more efficient in terms of developer time and give much better wins. And a couple of stories that I think illustrate this quite nicely. So this was a list view. It was an internal page used by our finance department, and it was taking longer than 30 seconds. And at that point, the server was timing out, and so our finance team couldn't access the invoice pages. There were a few things that were slowing it down. The search at the top was you could type in anything, but it would search the invoice field, the client field, hire a first name, hire a last name, freelancer first name, freelancer last name, lots of things. There was loads of data being fetched. There was 17 joins. To make things worse, we had this notion of batched invoices. And to make sure a batched invoice wasn't split between 2 pages of pagination, it was actually doing this query 3 times, once to get the main result and once to check the invoices, a batch wasn't split between 2 pages at the beginning and the end. So it was a really slow page. And so I started kind of looking into it, and I made a few improvements. And I got it down to about 17 seconds, which was still kind of not great, but it was better. So I sort of went along, cap in hand, to the finance team, and I said, I'm really sorry, it's still so slow, but at least it's usable. And I started explaining to them some of the reasons which was making it slow. And I talked about the batch invoicing, and they said, we stopped doing batch invoices for this particular group 2 years ago. And then I spoke about the search thing, and they said, we're only ever going to use this view to type in an invoice number. That's what we care about. We don't deal with names and things. And so I'd spent all this time trying to optimize this thing, when in actual fact, it wasn't a performance problem, it was a communication problem. So understand your requirements and your users. question functionality. I think performance shouldn't dictate to functionality. That's the kind of definition of premature optimization. If you do that, you end up with a blazingly fast site that does nothing. But when performance has become an issue, I think it's then right to question functionality. Notice changing functionality doesn't necessarily mean making it less useful. So a really good example of this is, I mentioned pagination earlier. So we have a lot of list views in our site. They're all paginated. And they all do a count. Now, in Postgres, as tables get big, doing a count is really, really expensive. And so a lot of these pages were getting really slow. It hadn't been a problem historically, but as we grew as a company, it was getting worse and worse. So we had a timesheets page that was taking 11 seconds, and our pagination components looked like this. And I spent a bit of time thinking about different things I could do to speed up the counts, maybe some database tuning. Maybe I could use the explain analyze to get an approximation of the row count rather than doing an exact count. That would have been a lot quicker. But actually, there was a far simpler solution. Just use a previous next. Nobody cared about the total amount. All they wanted to do was look through the first few pages. And so taking a step back and thinking slightly outside the box was A, a lot easier in terms of developer time, and B, actually a lot more efficient than whatever my clever solution would have done anyway. Here's another example. So we had this view. It took 22 seconds. And as you can see, 21 of those seconds are doing this one query. This is the query. It's not important what it is. I spent a bit of time playing about with things, trying to make some improvements. I made some pretty minor improvements, but we'll be talking like 17 seconds, not 22 seconds. And this was a user-facing page. The problem was that it was missing an index. This table was recording every single search. So if you think thousands of daily users, each of whom are doing lots of searches, this table grows pretty big pretty quickly, and it's doing a sequential scan through the whole table. The problem was it was a third-party package. And I was thinking, okay, I could fork the package, could maybe do a pull request, I could add a kind of standalone migration to add the index, and I was weighing up my options. And I thought, whilst I'm doing this, I might as well ship the improvements I've made. Got something to show for the day. And I thought, before I do that, I better do some click testing, make sure I haven't broken anything. So I went to the page, and I couldn't see, sorry, I should have said, this is for loading search suggestions. And I couldn't see the search suggestions. And I thought, oh, that's weird, I hope I've not broken anything. So I dug a bit deeper. It turns out we'd actually removed this functionality a year earlier. But when we removed it, what we did was we just got rid of the UI, and we were still passing the data back. So again, I'd spent all this time trying to optimize something that didn't need optimizing. And kind of the idea is understand the full picture. Don't reach straight for the hammer, especially with legacy code. There have been a few situations where legacy code have been an issue with performance. I'm going to skip this next one. The 2-second summary is fix the data, not the code. But we made some big speed ups there. So low-code solutions require a step back, but often provide a much bigger speed up for far less developer effort. And you can still use the hammer. You can do these thinking outside the box ways of speeding things up, and then use all your other performance tools to maybe get that last 10%. But think about other options before you reach for the indexes and the ORM tweaking and things like that. The hot path. So this is the really critical bit that all of your requests go through. So for us, it's the middleware, the context processors, and our base templates. If you're serving up JSON via GraphQL, it might be different. It would be, all the extensions you have wrapped around your GraphQL endpoint. But whatever the path is that all of your requests go through, I think is an area where it's worth really optimizing things. A good metric of this is what's the minimum 5% of all your requests? Because by doing that, you get views that are basically spending no time, and you get a measure of how much time you're spending in that critical section of the path. So back at the beginning of the year, you can see we were spending 100 milliseconds on every single request. And we were able to make some pretty big speed ups. One thing we did was we made all of our context processors lazy. So instead of doing this, we used simple lazy object. And what that does, it means the expensive calculation is only executed when you access the thing. So there were lots of things we need for lots of templates, but not all templates that were expensive to calculate. And that made a difference. Another thing, better caching. So I think in the past we've tended to think of caching. So each of these hits here is a hit to the cache. This was a load of assets we had at the top of every HTML page, and we included an SRI hash. So that's just a code that lets the browser know the asset hasn't been tampered with. You do want to cache those, but we're getting the same 10 SRI hashes every time. So instead of doing 10 separate hits to the cache, just do it in one. Cache the whole partial rather than the individual SRIs. The lesson there is to think about your cache in a similar way to what you'd think about the database. And so this big drop, it wasn't the things that I would have expected it to be. It was 10 milliseconds here, 20 milliseconds here, that we identified through this more systematic profiling that we wouldn't have noticed by looking at kind of individual kind of problematic views. And whilst each of these things on their own was small, it added up to a really dramatic effect. And actually, that graph does go down by another 10 milliseconds later on, which is what this one was about. So, yeah, where does that leave us? Well, I think if you were to ask me a year ago, what are the issues with our site? I would have said it's definitely lots of N+1 issues, lots of indexes missing. And it turned out to be all of the things that I didn't know that made a big difference. I think it's worth saying also that this is only half the picture. I've focused very much on the back end because this is Django, but the kind of network layer is another whole area, and there's no point serving your request super fast if you then have 2 seconds with a massive JavaScript framework waiting to render those things. So yeah, that's something that I just thought was worth mentioning. But I hope that's been of some interest to you, and thank you for listening.
All right, thanks, Tim. I think we have time for one question.
Do you have any thoughts about which of the profiling tools are worth paying for? Because they all give you like some tools that are free and then charge you a lot for more. When you're getting this like continuous, this proactive profiling going.
Yeah. I feel like after this talk, I should work as a tech evangelist for one of these firms. So like the one I've used most is Datadog. I know that's really expensive. I find it really, really useful. I've also used Sentry. So we use that primarily for exception handling, but kind of when they launched their APM stuff, we used it for that as well. I don't think I'd like to comment just because I kind of took a quick look at some of the other tools in preparation for this talk, but because I've not really used them in anger, I feel it'd be unfair to recommend a particular tool. I do think that very likely fluency in the tool you choose is probably more important than the particular tool. Thank you.
Okay, thanks. Yeah, I'm sure Tim will be around to answer questions in the hall.
Yes, do come say hi. Thank you.